Well, of course, clearly became Zygmund's student. He had a large number of students. There was a group of people. Some of the people who were students just at the same time as I was as a student were Guido Weiss and Mary Weiss.
And these people were grad students also.
Yeah, so what Zygmunt had is he had his seminar. And part of what he did when he had many students, which he did at that time, is that he would assign a topic to each student. Read a paper, a particular paper that's been around for a year or two or three, and you were supposed to present that paper, and then the idea was that once you got to know the subject a little bit, maybe you'd work on that subject. He was not very good about assigning you a problem. I mean, it was more that you sort of hung around him. He had certain attitudes about mathematics, you know, certain points of view, which he stressed, and those were very important. But as far as assigning problems, he never assigned me a problem, except that he asked me, and this was very important, he asked me to talk about interpolation theory. So Calderon and Zygmunt had just a year or two before written a nice paper on the Riest-Thoren interpolation theorem. So I gave this talk. I wrote a thesis on some minor series of little results on my own. Mm-hmm. Then he looked at it and he said, okay, that's enough for a thesis. That was it. I mean, he wasn't really very interested in it. But one of the things that Zygmunt was always coming back to was the two things. One, we wanted to talk about various extensions of Fourier analysis from one dimension to higher dimensions. So part of his point of view was, in one dimension, what he called complex methods were fundamental. Complex methods meant that you had the unit disk, and you had holomorphic functions in the unit disk, and the methods which used conformal mapping or various other things were very important in proving theorems about Fourier series. Now, he was very interested in higher dimensions, and of course, you couldn't use complex methods. So you had to develop what he called real methods. And of course, at that time, he was working with Calderon, and they did this theory of singular integrals, which extended Marcel Ries's theorem about. So he was always complex, the passage to several variables and the idea of developing real methods was very important. So I started to read about multiple Fourier series. And I read a paper of Bachner, which I liked. So I started to talk to Zygmunt about it. And he didn't think that multiple Fourier series was an interesting subject. He thought it would be sort of a routine extension. Maybe I'm not doing justice to what he really had in mind. But it would be a routine extension of the one-dimensional theory.
So on the one hand, it's very important to extend from one dimension to n dimensions, but on the other hand, multiple Fourier series were routine.
Well, because when he thought about Fourier series, he also thought about these various questions about convergence, and you know, what you can find in his book, Trigonometric Series. So you can, if you look in that direction, maybe he was absolutely right, but it depends where you look. So anyway, he didn't think it was so interesting, but I thought, and I learned from Bachner the following thing, which was that in higher dimensions, what Bachner called, there was a critical index, and the critical index was n-1/2, where n is the number of dimensions, because summability, Bachner-Riest summability above that order was like the usual thing in one-dimensional Fourier series, and below that order, it was very mysterious. Nothing was said, but of course it was clear that for order 0 L2 or order epsilon, various L2 theorems held. That was clear, but maybe that wasn't stated. So that was something that I thought about. Well, anyway, then there was one summer in 1955, he said, I'm going off to Ithaca for a month to visit Marquette. He said, what are you doing? Of course, I said, I'm not doing anything. So he said, come to Ithaca. So I moved to Ithaca for a month, and I saw him from time to time. But then in the library there, I realized that my interest in interpolation theory fitted exactly into that problem, because the critical index was good for L1 or something, and there was the L2 theory, so there should be something in between, and so you should be able to interpolate this result, and so you should be able to use operators that depend analytically. So that worked out very well.
Everybody thinks so.